Welcome to Stars and Shortwave. I'm your host, Hastings Saunders, and today we will be going into the not-so-brief history of literally everything. Of course, we're going to start at the beginning with what is everything and where did it come from. We will start at the very beginning. Here we have the universe before anything interesting really happened. Or, well, we don't really know because any mathematical models break down a few milliseconds before we can reach this point. Though at this point in history, we have literally everything that will become the universe crammed into this infinitely dense point, smaller than the head of a pin. Anyway, let's hit the play button, and then the pause button again. There. Okay, now we're in the Planck epoch, the very first era in the history of everything. This period lasted from the very beginning of the universe to 10 to the negative 43 seconds after that. In this incredibly small amount of time, the universe is still too dense and hot for anything to form, with temperatures potentially reaching billions of degrees. At this point in time, even the four fundamental forces of the universe, gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, were all unified as one force driving the universe apart. Let's move another split second forward. We are now in the Grand Unification epoch, which lasted from 10 to the minus 43 seconds to 10 to the minus 36 seconds after the start of the universe. This is where things start at least making a little sense. As the universe cools, even just a little bit, physics starts being able to work in a way we understand. Quantum fields, which dictate how matter behaves, start to form, allowing interactions to begin to happen. Also, the unified force of the universe begins to split, in which gravity now becomes its own thing, but all the other forces are still combined, making up the electrostrong interaction force. Some small amount of time after this force eventually breaks up into electromagnetism and the strong and weak nuclear forces. Next, we skip ahead 10 to the negative 4 seconds to the start of the next era where things really get going. The universe's expansion speeds up drastically, going from the equivalent of half the width of a molecule of DNA to 10 light years in diameter in almost an instant. There's good evidence this happened, but so far the reason for it is still unknown. By this point, the stage is set for some really interesting things to start happening. But the universe waits a couple more nanoseconds until the quark epoch, at 10 to the minus 12 seconds after the universe began. Here, quarks begin to form and bounce around, still at an energy level too high to form any larger particles. They're joined by leptons and antiparticles and the soup of ultra-hot quark gluon plasma. By 10 to the minus 11 seconds, things had cooled down enough for the quarks to begin forming baryons, that is, the protons, neutrons, and electrons we all know and love, in a process known as baryogenesis. At this time, it seems likely these particles would have been formed alongside antiparticles in an equal amount, but for some reason, it seems that there are far more normal particles than antiparticles. We now move a massive amount of time forward to an entire second after the beginning of everything. Some primordial black holes begin to form. In the chaos of the young universe, some particles underwent gravitational collapse, creating tiny black holes. In this time, photons become the dominant force in the universe, formed from the annihilation of leptons and antileptons. Within 2 and 20 minutes after the Big Bang, hydrogen newly formed by the subatomic particles drifting around, undergoes fusion, forming helium, lithium, and a few other light element isotopes. And then, the universe went into the Dark Ages. Things were relatively quiet and cool, consisting of clouds of gas and dust floating through space for about 1 billion years. After a long period of inactivity, these gas clouds began slowly clumping together under the force of gravity, eventually reaching a mass and pressure where the individual atoms within the core of these clouds began to undergo fusion. These became the first stars, and deep within the nuclear furnaces of the cores, they were hard at work creating the heavier elements, such as oxygen, carbon, and even iron. Once these stars expended all their fuel, they underwent dramatic deaths, creating supernovae or black holes, and generating heavier elements in their last moments. Thanks to the sacrifice of these stellar pioneers, the universe was now stocked with a wide range of elements in the form of gas and dust clouds floating through space. These clouds eventually found their way into the gravitational grips of other newly formed stars, creating a ring known as an accretion disk. These disks are the birthplace of the first planets. Over millions of years, the gas and dust in these disks slowly clumped together into asteroids, which smashed together in a tumultuous cosmic demolition derby. Some of these asteroids clumped together into larger masses, creating the first protoplanetoids. Even these planetoids are not safe, however, and many smashed into each other or were flung out of the system or into the star due to the perturbation of their orbits by other protoplanets. Some of these protoplanets may have been captured by larger ones, becoming moons. Other moons may have been formed due to collisions shooting massive amounts of material into orbit around a protoplanet. After several billion violent years, these planets slowly ate up all the mass in their local regions of the solar systems and began to cool, forming the first planets. Meanwhile, the stars and black holes were up to something. Black holes, being incredibly massive objects able to add to their own mass by devouring stars, planets, dust, and gas, began creating collections of stars and gas clouds, shepherded into orbit by the black hole's massive gravity. A single black hole can have billions and billions of stars orbiting it, creating the first galaxies. Some galaxies, more massive than others, began pulling on others in gravitational warfare, causing collisions and clumping together into clusters, leaving large gaps of unoccupied space known as great voids. Having expended much of their fuel, the second, third, and fourth generation stars within these galaxies shed their outer layers or detonated in supernovae. The clouds of gas they left behind would become nurseries for new stars, known as nebulae. It is at this point we pause the universe again, as there is still much to cover. We will be diving deeper next episode on the nature of these nebulae, as well as the formation of a very familiar planet. If you enjoyed this video, please subscribe and hit the bell icon so that you can be notified about future videos in this series. Have any questions or comments? Leave them down below. That's all for now. And as always, I am Hastings from Stars and Shortwave. And keep your ears to the airwaves and your eyes to the skies.